Hello students, welcome to the class of Software Engineering. In today's session, we are going to begin with a new module, Module 3. Let us discuss about system models. What is a system model? A system model is the process of developing abstract models of a system. So we are trying to develop an abstract model for our system which we need to build. So this model actually helps the analyst to understand your system and even understand what is the main functionality of the system, what services your system should provide, what are the constraints, what are the requirements. All those things will be able to understand easily. So models are actually the best way to communicate with the customers. So models, if you have the representation of models of your system, then it will be very easy to communicate with the customers. So each model will present a different perspective or view of the system. So the models need not be same for each and every person. It might vary, but the functionality remains same. So models can be represented in different views, but still you can convey or communicate with your customers and try to explain what that model is going to depict. So we'll see the different perspectives or the different views of your system. First one is external perspective. So what is this external perspective? It mainly shows the system's context or environment of the system. So you have a system, so it will show the system's context, means it is nothing but the boundary of the system. So what all other systems or subsystems surround your system, okay, or even it can highlight the environment of your system. So how those are going to mainly influence your system will be easily understood by this external perspective view. Second one is interaction perspective. So the term itself, you can get to know that it shows the interaction between the system and its environment. So how it's going to influence the environment or affect the environment, or what might be the impact of the changes made in your system. We can see that one, and also it can be the interaction between the system and its components. So interaction perspective might also show the interaction between the system and its components. So several components you have, so you are going to mainly highlight the interaction. Third one is structural perspective. This one mainly shows the organization of your system or structure of the data. So it can be any data you're representing your system. You can also show the structure of your system, structure of that data. So it mainly shows the organization of your system, how exactly you're organizing your system, because your system consists of several components, no? So how we are going to organize those components, and also the structure of the data. Data means you might be having different classes, objects, so it gives an overall picture of the structure of those data. Fourth one is behavioral perspective. This mainly highlights the dynamic behavior of the system. So here, since it is dynamic behavior, so you will be going to know when your system means how your system responds to particular event, input event or stimuli. So what will be the change in the state of your system, and what state it might have reached, what is the output state of your system. So once some input stimuli is given to your system, then some action will be performed. So your state of the system will be changed. So all those things will be shown in this behavioral perspective. So we have something called UML, Unified Modeling Language. I hope you have heard of this word, UML, Unified Modeling Language. So why I'm using this word is because we are using this UML notations only, okay, to represent the models. So it is the standard graphical notation for real world objects. So it is one of the standard graphical notation for real world objects. We will see in detail because the entire module we are going to learn about UML diagrams only. So there are 5 diagrams used in UML. First one is activity diagram, second one use case diagram, third one sequence diagram, fourth one is class diagram, fifth one is state diagram. So these are the different diagrams used in UML. So first one, let us see, that is the activity diagram. So by the word itself you will get to know activity. Mainly it shows the activities involved in a process of your system. So some process will be functioned in your system. Okay, n number of processes might occur in your system. So what all activities are actually involved in that process can be highlighted or represented using the activity diagram. Second one is use case diagram. Use case, already you have studied in the first module. So it shows the interaction between a system and its environment. So use case diagrams we are using when you want to show the interaction between a system and its environment. Third one is sequence diagrams. So sequence diagrams mainly show the interaction between actors and the system, or it can be actors and the system components also. So that is the sequence diagram, mainly shows the interaction between actors and the system, or it can be between the system components. Another one is class diagram. So class diagram mainly shows the what all classes are there in your system, and also how we are going to represent those classes, and it also mainly shows the association between these classes. Association between these classes means it mainly shows the relationship, how one class is connected to another class. Okay, so class diagrams are very useful. So it mainly shows the different classes or objects I can tell, and mainly it shows the association, that is the type of relationship between each class. Fifth one is state diagram. State diagram. So state diagrams is when I have told that whenever your system receives some stimuli, then it will respond to that stimuli and certain action will be performed, isn't it? So how will you show that? That is through the state diagrams. So mainly shows how the system reacts to internal, either it can be internal event or external event. So these are the 5 diagrams used in UML. Keep in mind, activity diagram, use case diagram, sequence diagram, class diagram and state diagram. So all in this entire module you are going to study about these diagrams. We will discuss about context models. context model. So the word is new for you, context. So it includes the functionalities that the system provides. So you are building a new system, you think what all functionalities your system should provide. So all those should be included, and context models are used to illustrate the boundaries of a system. So that is important. So what all other systems are there in the context of your system, that is the boundary. So how they are interacting with your system means you need to know that which all other systems are surrounding your system and what functionality they are going to provide. So we will take an example of our previous case study, MHC PMS system, Mental Healthcare Patient Management System. So already you know about it, but once again I'll repeat what it is. This system is intended to manage information about patients attending mental health clinics and the treatments that have been prescribed. So in developing the specification for this system, you have to decide whether the system should focus exclusively on collecting information about consultations, that is, using other systems to collect personal information about patients, or whether it should also collect personal patient information. So you know what is for what purpose the system is being built, MHC PMS system. So the advantage of relying on other systems is, one, it avoids duplicating of your data, and the major disadvantage is using other systems may make it slower to access the information. So if these systems are unavailable, then the MHC PMS system cannot be used. Correct? Yeah. So this is actually the context model of your MHC PMS system. So look at the representation, how we are going to represent the context model. So at the center you have the stereotype system. So what is your system? MHC PMS. This is your system which you are going to build. So what is there in the context of your system, surrounding the system, or what lies in the boundary of the system? These are the other systems. So some or the other way they are influencing your system. So you can see here, one is patient record system. Second one is admission system. Third one is prescription system. Fourth one is appointment system. Then HC, healthcare statistics system. Another one is management reporting system. So how we'll see what all functionalities are being provided by this system. You can just see here is the admission system. So the receptionist will actually make the patient to be admitted to the particular clinic, correct? So that is the major functionality of the admission system. Patient record system. So once the patient is being admitted, his personal details, all those will be stored in the database. So that is another patient record system. Prescription system, which this system is used to maintain the details of all the prescriptions taken by each patient per day in that clinic. Then appointment system. Appointment system which is used to actually keep track of all the appointments, making the appointments, scheduling the appointments for the patients, isn't it? So for that purpose this system is being used. Then management reporting system. So it is something like monthly you're going to generate the report of your clinic. So how much patients have entered into the clinic, what type of treatment they have taken, what is the cost of their treatment, all those details will be reported. So this system will maintain all those details. HC statistics system, healthcare statistics system. So mainly all those cost or the expenditure details will be maintained here. So figure 1 is a simple context model that shows the patient information system and the other systems in its environment. So the MHC PMS is connected to an appointment system, already we have discussed, and a general patient record system with which it shares the data. Also, the system is connected to systems for management reporting and hospital bed allocation, and a statistics system that collects information for research, so that all the statistical data, how many patients have been visited, have taken the treatment under what is the rate of recovery, all those statistic details are being collected in order to do some research. Finally, it makes use of a prescription system to generate prescriptions for patient's medication. So once the patient consults the doctor, so he will be giving the medication. So that prescription needs to be generated. So one thing keep in mind, context models do not show the types of relationship between the systems in the environment and the system that is being specified. It's like I've told that this is our main system and these are the other systems in the context of our system. But it doesn't mainly show how this system is related to our patient record system, but mainly it will highlight the functionality of that system. Keep in mind, it will just highlight the functionality of the system, but it will not show the type of relationship it is going to have with your system. So that is about the context models. Context models. So here we have studied what is a context model. We have taken an example. So mainly it illustrates the boundaries, systems and the boundaries or the context of your system. Let us continue with context models. Also, we can see that context models can be used with other models also. Other models means such as you can use with business process models, which describe the human and automated processes involved in the software system. Okay, so we'll see an example for it. We have the processes used in MHC PMS system. So we'll see another figure. This is the figure 2, which shows the process model of involuntary detention. So look at the representation here. It's a bit different, no? So we are combining the context model with other models. Other models are nothing but your process model. So we are seeing the diagram of process model here. Okay. So this process model is for involuntary detention. So figure 2 is a model of an important system process that shows the processes in which the MHC PMS is used. Now here the problem scenario is, see, sometimes the patients who are suffering from mental health problems, they might be a danger to others in some cases, or they might harm themselves also. We cannot predict it, isn't it? So when it might happen, they can also harm others or harm themselves. So because of their health problem. So such patients may have to be detained against their will in a hospital, because they should not cause any problem to outside, isn't it? So that's why they must be detained. So that's why we have this process model of involuntary detention. So we have to detain such patients and put them into a hospital for treatment. So all this should be administered. The decision to detain a patient must be regularly reviewed so that people are not held indefinitely without good reason. So you have to decide whether the patient has to be detained. So you have to see his exact problem, health problem, and then only come to the decision for detaining him. Else, without any reason, you should not detain such patients. Okay, so this is the process model now. So we have, this is the initial state, filled circle, blue color shows the initial state, and here your double circle, which is the final state. So here you can see confirmed detention decision. So what is that? So here the start of a process is indicated by a filled circle and the end by a filled circle inside another circle. You can see here in your figure the initial state. How do you begin? With the filled circle, and the final state is filled circle inside another circle. Okay. Now rectangles with round corners represent activities. Keep in mind what is this. So you have to represent it the same way. Okay. So that you need to look at the shape also. That is important. So you can see a rectangle with a round oval shape. Round corners. So you can see here this shape is actually a rectangle, but with round corners. Here also you can see round corners. Here also you can see. So it is actually a rectangle, but with round corners. So what do they represent? The activities. They represent the activities. Keep in mind, this is the initial state. Filled circle shows the initial state, and the final state is filled circle inside another circle. And then look at the shape here. It is actually rectangle with rounded corners that mainly represent the activities. So they tell the activities. Okay. That is the specific sub-processes that must be carried out. Now, also you have arrows. Can you see here? Arrows. Yes. So what do those arrows specify? The flow of work from one activity to another. You can see here. From this activity to this activity. So you have used arrows. So arrows represent the flow of work from one activity to another activity. Okay. Now when the flow from more than one activity leads to a solid bar is used to indicate activity coordination. A solid bar where we have used here. Can you see? What is that? It is used to indicate activity coordination. Also here also I have used the solid bar. Here also it is being used. So that indicates the activity coordination. So when the flow from more than one activity leads to a solid bar. So the change here you can see is when the flow When the flow from more than one activity, it actually leads to a solid bar. So there is flow of work from more than one activity, it leads to solid bar. Then all of these activities must be complete before the progress is possible. Okay, so you can see that the flow of work is from more than one activity that will result to a solid bar, so that all activities must be completed before the progress is possible. When the flow from a solid bar leads to a number of activities, these may be executed in parallel. These may be executed in parallel. So what they are telling is, when the flow from a solid bar leads to a number of activities. This example. Number of activities. So how can I tell now? Sorry. Yeah. Here you can see this. Number of activities has been there. So when the flow from a solid bar leads to a number of activities, these activities may be executed in parallel. Now I can execute these all activities in parallel. So when the flow from your solid bar leads to number of activities. Therefore, in figure 2, the activities to inform social care and the patient's next of kin and to update the detention register may be concurrent. So what you can see here is, these activities can run parallelly because the flow from the solid bar leads to more than one activity. Then you execute those activities parallelly. But one more thing I have told is, when the flow from more than one activity leads to a solid bar, then all of these activities must be completed before progress is possible. So this, let us see in detail about this process model. You can see this is the initial state. So you have to confirm detention decision. So now you have to decide whether that patient has to be detained or not. So you can see there is a solid bar. So it leads to two activities. One is inform patient of rights. So there is some patient of rights law also. So you have to inform them. Such a case is there. And then record the detention decision. So how can you record this? That is through this MHC PMS system. Keep in mind. Okay. Now from here, you have to find the secure place. Na? So what happens here is a decision is made. You can see a diamond shape here. Can you see a diamond shape? Yes. So you have used the diamond shape in while drawing the flow chart while studying your C program. So that is decision maker. So here we are deciding whether that patient is dangerous or not dangerous. So if he is dangerous, then you have to find a secure place to put him. So we are going to inform to the police station. So if you don't get a secured place, then what to do? Just send him to the police station. If you get a very secured place, that means where he has to be treated, then transfer to that secure hospital. Now if he is not dangerous, so transfer to secure hospital. If it's not dangerous, then admit to hospital. That if it's not dangerous means you can do treatment within that MHC PMS system only. So admission system for which one? MHC PMS system only. But if still he is going to cause any problem to others, means you have to transfer him to a secure hospital. Now all these activities from the solid bar will result in these activities which will be executed parallelly. You have to inform the social care. Yeah, that is one thing. Inform the next of kin, his relative, and you need to update in the register. Okay, so that will be updated in your MHC PMS system. So this is the final system. Clear? So this is about the process model. Let us discuss about interaction models. Interaction models mainly show the user interaction. So it might involve input or output or interactions between the system. Also it can show. So it shows the interaction between different components of the system. So there are mainly two types of interaction model. First one is use case modeling. Second one is sequence diagram. So we have two types of interaction model. So now we are clear that interaction model mainly shows the interaction between the different components of the system. And there are two types of interaction model. One is the use case modeling and another one is the sequence diagram. Let us first discuss about use case modeling. So you have studied about use cases in module 1. So we'll study in detail about it now. So use case modeling is used to model interactions between a system and external actors. So you know what is an actor now? Who is an actor? So external actors can be users or other systems. So let us see one simple example. So in this figure, you can see that the use case name is transfer data use case. Transfer data use case. So we are taking the same example, MHC PMS system. So you can look at this figure. We have one stick figure. What does it represent? Actors. Those represent the actors. So this stick figure name is medical receptionist. So medical receptionist is one actor. Another one, you can see one more stick figure, that is an actor. Patient record system. So this actor is an external system, I can tell. It is an external system. And the interaction is represented using ellipse shaped. So what is the interaction name? Transfer data. So you will get to know that medical receptionist is transferring the data. Now let us see the explanation. There are two actors in this use case. The operator who is transferring the data and the patient record system. So there are two actors. One is the medical receptionist. Another one is the patient record system. The stick figure notation is used to represent human interaction, either users you can represent or any other external systems you can represent. And also you have the arrows. Can you see the arrows which indicate the interaction? Indicate that the medical receptionist initiates the transaction and data is transferred to the patient record system. So when you look at this arrows, you will clearly understand that medical receptionist actually transfers the data to this patient record system. Now you have seen that diagram. Let us see the tabular way of representing the use case. So the same use case I am taking, transfer data use case. So we will have a tabular description now. So first, can you see that MHC PMS system and transfer data? What is that? Name of the use case. Now first you are mentioning actors. Who are all the actors in the system? So already we have learned it is medical receptionist and another one is the patient record system, that is PRS in short. Now next you have to give the description of that use case. A receptionist may transfer data from the MHC PMS to a general patient record database. So that will be actually maintaining the details of all the patients. The information transferred may either be updated personal information. So whatever information or data is transferred, what kind of data it is. Either it can be the personal information of the patient, or it can be the summary of the treatment of the patient. But keep in mind personal information like address, name, date of birth, phone number. So if suppose any changes has been done, then again that should be sent to the database and it should be updated in the database. So what is the data here? Patient's personal information like name, address, phone number, and one more is treatment summary. Stimulus, user command issued by medical receptionist. So once the user enters the clinic, so that user you need to admit to the clinic, isn't it? So you have to take his details and then enter all the details and then send the details to the PRS. So PRS will store in its database. Response, confirmation that PRS has been updated. Now medical receptionist will store all the details of the patient and also will transfer that data. But from that side also you have to get the response or confirmation. So whenever a field or a data is entered, you have to get either a dialog box and you have to get a message like the field is entered or the data is being entered or such a patient's data has been entered successfully. That means that it has been stored in the database successfully. Else you will get a confirmation that the details are incorrect or unable to store. Next, comments. The receptionist must have appropriate security permissions to access the patient information. So one thing is receptionist should have all the security permission to access the patient information, and there should be proper authorization. Only the receptionist and the PRS system can access that data. Next, use case modeling. Use case modeling. Same thing, we are seeing the use cases involving the role medical receptionist. So what is the role being played by this actor? So the actor name is medical receptionist. So either he can register the patient initially. So once the patient enters into the clinic, he can register that patient, store all the details of that patient. Unregister the patient means if the treatment has been completed and he has been cured means you can unregister that patient. Then medical receptionist will have the rights to view the patient information, can also update it. Then transfer data, already you know that details whatever is been entered by the medical receptionist, that can be transferred to the database. And contact patient, even the medical receptionist can contact the patient because as the mobile number is stored, and say about the next appointment dates, can give a reminder to the patient. So all these are the roles or type of interaction played by this medical receptionist. Let us see into the sequence diagram. So this is another type of interaction model. Earlier you studied about use case modeling. Now we are going to study about one more, that is sequence diagram. This is very, very important. See, sequence diagrams are used to model the interactions between the actors and the objects in a system, or it can be interaction between the objects itself. So sequence diagram is mainly, it shows the interaction between the actors and the objects or between the objects themselves. Now let us see an example so that it will be clear for you this sequence diagram. So here we have the figure, that is sequence diagram for view patient information. So for which one? View patient information. So who can view the patient information? Only the medical receptionist. So you can see here the actor. Who is the actor? Medical receptionist. So sequence diagram shows the interaction between the actor, and these are the classes. Okay, so classes, patient information is the class and P is the object. So mainly it is showing the interaction between the actor and the objects. Let me explain about it. Figure 6 is an example of sequence diagram that illustrates the basics of the notation. So this diagram models the interactions involved in the view patient information use case. So who actually, that is the medical receptionist, can see some patient information. Now, so I told that this stick figure is an actor. Actor is medical receptionist. Now what are these? Patient inform, MHC, PMSDB, authorization. These can be systems or classes, I can tell. But here actually we are representing instance, objects of the class. So P colon, no, this P is nothing but object of this class, patient information class. This D is an instance or object of this MHC PMS DB system. This AS is an object or instance of this authorization. So you can see that the objects and actors involved are listed along the top of the diagram. So on the top of the diagram, you can see we are representing the actors and objects. Three objects are there. And with a dotted line drawn vertically from these, you can see here a dotted vertical line is drawn now from all these three. All these, from actor also, from these objects also, a vertical dotted line is drawn. Now, interactions between objects are indicated by annotated arrows. By how the interaction between the objects, you can see here, from this object to this object, it is represented using the annotated arrows. Means arrows are represented, with that you are giving the message also, passing the message also. The rectangle on the dotted lines indicates the lifeline of the object concerned. Now this is very important, because actually vertical line is drawn from all these objects and actors, but you can see a rectangle on the dotted line. So what does it indicate? That indicates the lifetime of your object. So during that lifetime, it will only during that entire lifetime your object will exist. Otherwise it won't exit. So you can see here, what is that lifeline? The time that object instance is involved in the computation. In that process, okay, how much time your object or instance is being involved. The sequence of interactions is read from top to bottom. Keep in mind how you are reading the sequence of interactions from top to bottom. The annotations on the arrows indicate the calls to the objects, their parameters and the return values. Can you see that? So whatever annotations on the arrows you have put here, view, info, report, authorize. So it's nothing but call to your object. It's like a function call to your object. So inside the bracket you are passing the parameters and the return values. So we'll see the step, okay, one by one. First, let me begin the first step. the medical receptionist triggers the view info method in an instance P of the patient info object class. So what you can see is who triggers now. Actually, it is the medical receptionist. So it makes a call to this object class. I can tell what is this patient info class and what is the object P. Keep in mind. So it will make a call to this object class. And what is that function call name? View info. And what you are passing PID. So it can be patient ID, which is unique. Keep in mind it is unique. Okay. So through this PID only you can access that particular patient's information. Now next what happens? The instance P calls the database to return the information required, supplying the receptionist identifier to allow security checking. So you can see here now, in turn, this object P or instance P will make call to the database. DB means database. So why? Because all the details of the patient will be stored in the database itself. So it will again make a call. So you can see report. Means it wants the report of that patient. So entire details of that patient. So what it requires is being passed in this parameter list info, PID, patient ID, because you want to fetch that particular patient information only. So how is it possible? Using the PID. It's like your USN. Okay. Then UID. What is this UID? Anyone knows? See, this is a unique ID given to the medical reception. So your database should know that who is actually sending the request. Okay. So if it is the request from the medical receptionist only, then the database can send the report, isn't it? Because all those data are very confidential. It should be confidential. So there is a higher security in this case. Okay. So once the DB will check for the medical receptionist ID and it will verify, and then only it will send the report. So there is security being maintained here. Okay. Next, third, the database checks with an authorization system that the user is authorized for this action. So it will authorize now. First authorize the medical receptionist. So we'll check. Otherwise what happens? The detail can be sent to a hacker also. So it will authorize. So you can see here authorization. Authorize info UID. That is the medical receptionist UID. Unique ID. So now authorization process is done. Okay. If authorized, the patient information is returned and a form on the user screen is filled in. So if yes means authorization, okay means patient information is returned. If authorization fails, then there will be error. So cannot access that patient's information. Okay, if authorization fails, then an error message is written. Can you see your error message? No access. So that is more important. Now can you see the rectangle on the dotted line indicates the lifeline of that object. So this medical receptionist actually will trigger the whatever interaction need to be take place. So its lifeline starts from here and it will be completed till the end, because medical receptionist has actually sent a request for the report to view the patient information. So until it receives it, gets the acknowledgement, its lifeline is this much. Now here also same thing for your instance P, the lifeline is this much. For instance D, look here it will receive the message and then it will authorize. Authorization is only this much lifeline. Just checking whether it is authorized user or not. Then that object doesn't exist. Can you see here whether it exists? No, AS object doesn't exist. Thank you.